Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, let us see about how to find the input impedance of transmission line. So this is a transmission line of length L characterized by propagation constant gamma and characteristic impedance Z0 is connected to the load of impedance ZL. And this transmission line is supplied with a generator voltage VG. So let us find the input impedance first, then following we will find the standing wave ratio, that is SWR, and power flow on this line. Here the transmission line is extended from Z is equal to 0 at the generator side and Z equal to L at the load. We already know the voltage and current equations in transmission line. So Vs of Z is equal to the incident voltage plus the reflected voltage. Incident voltage is V0 plus, it is traveling in a positive Z direction, so e power minus gamma Z plus reflected wave is having the amplitude V0 minus and it is traveling in a reverse direction, so e power plus gamma Z. Similarly, for the current equation, Is of Z, it is equal to voltage by impedance, right? So V0 plus by Z0 e power minus gamma Z. Here negative sign comes because the ratio of ratio of minus V0 minus by I0 minus is equal to Z0 characteristic impedance. From that only we are writing here negative sign. So the current equation also is the sum of incident current and reflected current. Same we are representing in voltage and impedance. So here from this equation we can see that we need to find the incident voltage and reflected voltage. To find that we have to apply the terminal conditions. First we are going to apply the conditions at the input side. At the input side we know that Z equal to 0. So at Z equal to 0, the voltage is equal to V0, and similarly at Z equal to 0, the current is equal to I0. So this we are going to apply in the voltage and current equations. So if we apply Z equal to 0, this is equal to V0, which is nothing but equal to V0 plus V0 minus, since e power minus 0 and e power plus 0 is 1. Similarly, if I apply for the current side, I get I0 is equal to V0 plus minus V0 minus divided by Z0. So after rearranging, I get this term. So in order to find V0 plus and V0 minus, what we have to do, we have to add these two equations as well as subtract these two expressions. So adding these two, we get 2 V0 equal to V0 plus Z0 I0. Okay, so to find V0 plus, just we have to divide it by 2. Similarly, V0 minus, same expression we will get, only a negative sign in between because we are subtracting both the terms, right? We know that the input impedance at the input terminals of the transmission line is Zn. And here we are going to apply the input voltage V0 to the transmission line and the current I0. So these two things we should know, what is the current applied, what is the voltage applied. Both depends on the generator voltage. So V0 is nothing but, V is nothing but the supplied voltage Vg across the input impedance of the transmission line Zin divided by Zin plus Zc. Similarly, I0 is nothing but what? Ratio of voltage and current resistance. So it's here impedance. So Vg divided by Zin plus Zg. Similarly, we have to apply the condition at load. We have applied the condition at source and we have found the expressions for incident voltage and reflected voltage. Similarly, we have to apply the conditions at the load. There the Z equal to L. Okay, for that expression, VL is nothing but V0 plus e power minus gamma L. Instead of Z, L will come, plus V0 minus e power plus gamma L. Similarly, the current expression, IL, Z0 is common, so taken to the left hand side, V0 plus e power minus gamma L minus V0 minus e power plus gamma L. So to find the incident voltage and reflected voltage, that is V0 plus and V0 minus, what procedure we followed in the previous condition, we just added these two and subtracted these two expressions. So we get these terms. So now we are going to find the input impedance Zin, that is equal to ratio of voltage Vs of Z divided by the current Is of Z. That is, we have to find the input impedance at any point on the line. So at the generator, we already know general relation is Zn equal to Vs of Z by Is of Z. At the generator, we have already applied the condition Z equal to 0 and we have found these expression right. So it will be equal to V0 by I0. If you substitute V0 by I0, what you will get? V0 plus V0 minus divided by V0 plus minus V0 minus. This Z0 term comes to the numerator. Now what we are going to do after applying the voltage and current at the generator side, now we are going to express the incident and reflected voltage in terms of load voltage and load current. This we already found, right? V0 plus and V0 minus in terms of VL and IL we have found here at by applying the conditions at the load. So if you apply for V0 plus this particular term and V0 minus this term, similarly same expression but with a negative sign. After substituting, we have to club the VL terms on one side, Z0 IL terms on other side. We get VL into e power gamma L plus e power minus gamma L. Similarly, Z0 ZL Z0 IL, I'm sorry here, Z0 IL into e power gamma L minus e power minus gamma L. Same expression we get in the denominator but with the here also positive sign only, because I am clubbing e power gamma L, here minus of minus, entire thing is going to be plus here, right? So now we are going to apply the trigonometry. So we know that e power gamma L plus e power minus gamma L by 2 is equal to cos h gamma L. Similarly, e power gamma L minus e power minus gamma L by 2 is sin h gamma L. And after applying these, we get Zn equal to Z0 into VL for this cos h gamma L plus Z0 IL sin h gamma L, denominator VL sin h gamma L plus Z0 IL cos h gamma L we are getting. Now how this ZL comes, we know that ZL equal to VL by IL. So take IL out and we know that tan equal to sin by cos. So take cos outside, what you will get? Taking cos outside, we get cos as well as IL outside, we get VL divided by IL. So that turns out to be ZL plus Z0. Already we took cos out. So here cos is not there. So divided by cos, sin by cos is tan. Same we do it in the denominator. IL cos h gamma L is taken out. So Z0 will be their first term plus VL by IL is ZL. Sin by cos is tan h gamma L. So this is the input impedance of a transmission line for a lossy transmission line. Now we are going to find the same input impedance for the transmission line which is lossless. In that case, attenuation will be 0. Propagation constant will be equal to j beta. If you apply tan h gamma L, in that gamma j beta means we get a j tan beta L. Okay, h will be removed. And the input impedance will be equal to Z0 into ZL plus JZ0 tan beta L divided by Z0 plus JZL tan beta L. So we can see that the input impedance varies periodically with the distance from the load. So it depends on the distance L from the load. So this beta L term is known as electrical length of the line and which is measured in degrees or radian. Hope you understood how to find the input impedance of a transmission line from the voltage and current equations. Thank you everyone.